السلام عليكم ورحمة الله وبركاته طلاب المرحلة الأولى، شلونكم؟ إن شاء الله زينين. نسأل الله تعالى أن ييسر لكم وتجتازون هذا الكورس الثاني. بداية موضوعنا المادة مالتنا اللي هي Linear Algebra 2. Linear Algebra 2 الكورس الثاني Linear Algebra 2. Chapter 1 راح يكون Vector Space. نبدي بهذا الشابتر. بداية طبعا ناخذ تعريف الفيكتور سبيس. Definition. A vector space V over R is a set V together with a function plus defined from V cross V into V called vector addition. And another function dot defined from R cross V into V called scalar multiplication. Scalar multiplication. We require that the operations of vector addition and scalar multiplication satisfy the following 10 axioms. For all x, y, z belongs to V, and alpha, beta belongs to R. Axiom 1, A1, x plus y is equal to y plus x for all x, y belongs to V. A2 this is A2 x plus y plus z is equal to x plus y plus z for all x, y, z belongs to V. This axiom called commutative. This is called commutative, and this is associative. This is commutative, and this one called associative. This is 2. This is number 1. I will give you this papers by PDF file, send you PDF file, inshallah. And A3 there exists zero belongs to V such that x plus V0 is equal to x for all x belongs to V. This is A3. Identity. This identity. And A4 for each x belongs to V, there exists minus x. Minus x also belongs to V such that x plus minus x is equal to 0. This is A4. And A5 1.x is equal to x for all x belongs to V. And A6 alpha beta dot x is equal to alpha dot b dot x for all x belongs to V and alpha beta belongs to R, real numbers. A7 A6, this A7 alpha dot x plus y is equal to alpha dot x plus alpha dot y. This is for all x, y belongs to V, alpha belongs to R, real numbers. And A8 A alpha plus beta dot x is equal to alpha dot x plus beta dot x. This is for all x belongs to V, alpha, beta belongs to R. And A9, if x, y belongs to V, then x plus y also belongs to V. Number 810, last one, if x belongs to V and alpha belongs to R, then alpha x belongs to R, single element in R. This is, we call this, we say V is closed with respect to addition. And about this, we say V is closed with respect to scalar multiplication. We call 0 in A3 the 0 vector. And the vector minus x is called the additive inverse of x. This is page number 2. And now we go to examples. examples of vector space. Example 1. R is a vector space. If we identify addition of real numbers as the vector addition, as the vector addition and multiplication of real numbers as the scalar multiplication. يعني في هذا المثال راح يكون عندنا ال V هو نفسه يساوي R، وأيضا معرف على ال R الأعداد الحقيقية تؤخذ من الريال نمبر. السكيلر أيضا يؤخذ من، يعني الدالة مالتنا هنا راح تكون الفيكتور سبيس راح يكون معرف من X، يعني الجمع راح يكون معرف من R كروس R إلى R، والدوت راح يكون أيضا معرف من R كروس R إلى R. يعني راح ناخذ القيم من العناصر الفيكتور كفيكتور سبيس من R، والأعداد ألفها وبيتا ناخذ السكيلر ناخذه أيضا من R، والنتيجة راح تكون أيضا في R. وهذا المثال بسيط ومتحقق. جميع الشروط متحققة. في هذا المثال تلاحظ أن إذا أردنا نحقق الشروط العشرة، ال A1 X plus Y equal Y plus X for all X, Y belongs to R. That's right. It's correct. X plus Y is equal to Y plus X. And also axiom number 2 associative, this commutative, and A2 also associative for all X plus Y plus Z is equal to X plus Y plus Z. This for all X, Y, Z belongs to R. This is also correct for all X, Y, Z in R. And A3 also correct. There exists 0 belongs to R such that بحيث أن X 0 plus X equal to X for all X belongs to R. And so this is also correct. And A4 for all X belongs to R, there exists minus X belongs to R such that X plus minus X is equal to 0. This is correct also. and A5 1 dot x equal x for all x belongs to R. Also this is correct. A6 alpha beta dot x is equal to alpha dot beta dot x for all x alpha beta belongs to R for all. And A7 alpha dot x plus y is equal to alpha dot x plus alpha dot y for all alpha beta x alpha x y alpha xy belongs to R. And also this correct. This page number 3. And A8 alpha plus beta dot x is equal to alpha dot x plus beta dot x for all alpha beta x belongs to R, and this is also correct. And A9 if x y belongs to R, then this implies x plus y also belongs to R, and this is correct. A10 if alpha belongs to R and x belongs to R, then implies alpha x belongs to R, also correct. So R is a vector space over R. This is the first example. We take example 2. Example 2. Rn forms a vector space if we define addition by x1 x2 so on to xn plus y1 y2 so on to yn. This will equal x1 plus y1 x2 plus y2 and so on to xn plus yn. This is for all x1 x2 so on to xn y1 y2 yn belongs to Rn. And scalar multiplication by alpha dot x1 x2 to x n is equal to alpha x1 alpha x2 and so on to alpha x n for all alpha belongs to R and x1 x2 and so on to x n belongs to R n. We have to prove that Rn is a vector space over R. We have to prove all axioms. لازم نبرهن جميع البديهيات A1 إلى A10. 10 بديهيات لازم نبرهنها كامل حتى نثبت أن ال Rn هو vector space. We show that Rn is a vector space. Now we will prove all these axioms start from A1. We will show that Rn is a vector space. This is page number 4. This is for you. And now we try to prove Rn is a vector space. This is A1. Let xi yi belongs to Rn. This is mean that x1 x2 to xn and y1 y2 to yn belongs to Rn. x1 x2 xn plus y1 y2 until yn, this is will equal to x1 plus y1 x1 plus y1 x1 plus y1 and x2 plus y2 x2 plus y2 and so on xn plus until xn plus yn. And now this is in R. This is in R, and the commutative satisfies in R. We can commute x1 with x2, so we can say, we can write here y1 plus x1, and here y2 also in R, y2 plus x2, and here so on to xn plus yn. And now we can separate them. We can separate them by y1 y2 until yn plus x1 x2 until xn. We can say this is equal to x and this is equal to y, and that means x plus y is equal, this is x and this is y. And now we can say this is y plus x. This is commutative. X plus y is equal to y plus x. So this is proof of A1. Proof A1. Now if we want to prove A2, I think this is similar. تشبه ال A1. Prove A2. Here we need x, y, z. Let x is equal to x1, x2 until xn. Y is equal to y1, y2 until to yn. Also z is equal to z1, z2 until zn. And now A2, we remind A2 x plus y, this is brackets, plus z is equal to. And now we take x1, x, this is x, and y, this is y, and z, this is z. Take big brackets, square brackets, and we put here x, x1, x2 until xn plus y1, y2 until yn. This is square brackets plus z1, z2 until zn. And now we can sum this with this. This is equal to x1 plus y1, x2 plus y2, and until xn plus yn. This is brackets plus z1, z2 until zn. And this is, now we can sum this with this, this with this, and this with this by definition of addition vector. This is equal to x1 plus y1 plus z1, x2 plus y2 plus z2, and so on to xn plus yn plus zn. And now this is in R, and R, the associative, is satisfied in R. So we can here write this is equal to x1 plus y1 plus z1, x2 plus y2 plus z2, here brackets, square brackets, move here, square brackets, move here between y and z for all of them. And now this xn plus yn plus zn, and now we can separate them. This is page number 5. This is equal, and this is here. This will be equal to, this is will be equal to x1, x2 until xn plus y1, z1 y2 plus z2 square brackets until yn plus zn, this brackets, and this will be equal to x1, x2 until xn plus y1, y2 until yn plus z1, z2 until zn, and this is will be equal x plus y plus z, and this is exactly A2. We move brackets here between z, y and z, here y and z. This is associative, and A3, prove A3. I think this is clear because there is a zero vector. 0 belongs to Rn. Such that for all x is equal to x1, x2 until to xn belongs to Rn, zero plus x is equal to 0, 0 until 0 plus x1, x2 until to xn, and this is we sum will be x1, x2, 0 plus x1 is x1, 0 plus x2 is x2, and this for all n, 0 plus xn is equal to xn, and this is equal to x. So 0 plus x is equal to x. The second is proof of A3. And the proof of A4, proof of A4 for all x is equal to x1, x2 to xn belongs to Rn. There exists minus x belongs to Rn minus x is equal to minus x1 minus x2 and so on minus x n, and x plus minus x will be equal to x1 x2 xn plus minus x1 minus x2 until minus xn, and if we sum x1 plus minus x1 plus minus x1, x2 plus minus x2, and so on, xn plus minus xn, this will be equal 0 0 and for all 0, and this is equal 0, so x plus minus x is equal to 0. And proof of A for 5. Proof of A5. For all x equal to x1, x2 to xn belongs to Rn, 1 dot x is equal to 1 dot x1, x2, xn is equal to 1 dot x1, 1 dot x2, 1 dot xn, and this is equal to x1, x2 until xn. This is equal to x. So 1 dot x is equal to x. This is proof of A5. It's page number 6. And A6 prove A6 for all x is equal to x1, x2 until xn belongs to Rn, alpha beta belongs to R, we have alpha beta dot x. This is equal alpha beta dot x is equal to x1 until xn, x2 until xn, and this will be here is equal to alpha beta dot x1, alpha beta dot x2, and this is alpha beta dot xn, and this is in R, and R is a vector space, so we can move brackets here, we can move brackets here. This is equal to alpha dot beta dot x1 and alpha dot beta dot x2, and this so on to n alpha dot beta dot x n. This is will be equal to alpha dot beta 1 beta dot x1 beta dot x2 so on to beta dot xn, and this will be equal to alpha dot beta dot x1 x2 till x n, and this will be equal alpha dot beta dot x, because this is equal to x, and we now satisfy A6. Alpha beta dot x equal alpha dot beta dot x. I leave the other axioms A7, A8, A9, A10. This is for you. You should prove them. And this is page number 7. This is page number 7. لهنا انتهت محاضرتنا، ونشكركم على حسن الاستماع، وإن شاء الله تكونوا افتهمتوا المحاضرة بالكامل، وأي سؤال عندكم ممكن أن تكتبون وترسلونه، وإحنا إن شاء الله نوضح لكم اللي كان غامض عليكم، وشكرا.